Hi, I'm Aiden Schwalm.
I'm Avi Meron.
And I'm Alec Disha.
And right here we have our project 3, and we are basically a company called AAA's Delivery Service. We've designed a program that many different customers can actually utilize. We let other people use our program. And what this program does is essentially, since we're a delivery service, we'll get and receive a certain number of orders from customers, and those are in different locations. And basically, the program is designed to visit each one of those locations in the optimal amount of time and basically find the optimal route for a driver to complete all of those orders in exactly one trip. So here we started off with a few user inputs. Alec?
So for our program here, we randomly generate our data based off the size input a user inputs. So the intersections in our case are equivalent to the vertices of the graph, and then our roads are equal to our edges of our graph. The way I implemented the random generator is that I iterate through 10,000 values and slowly fill up one vertice at a time for 4 edges. When I reach 70% capacity or 70% of the vertices, I start allowing the maximum or the minimum amount of roads for a vertice to be 2. And so now we input how many orders we'd like to place.
So basically, when you input the number of orders, it basically takes that number. You take, let's say, 3 orders plus a micro fulfillment center, which is about 4 points of interest is what we consider. And amongst those 4 points of interest, we will then run a shortest path algorithm, whether it's Dijkstra's or Bellman's, depending on what the user decides. We run a shortest path algorithm from each one of those points. So the 3 order locations plus the micro fulfillment center. And then that will return the shortest paths, which we then use to create a new graph that will then later actually run another algorithm to find the optimal route. But
Essentially, yeah. So the user has the ability to choose Dijkstra's or Bellman's, and they're both all famous shortest path algorithms, and they'll return the time that it takes calculated by either algorithm, depending on the user's input.
Yeah. So in terms of Dijkstra's versus Bellman's, one has a better time. Dijkstra's has what's it called? A better time complexity. Yeah. Although it is a greedy algorithm, so it doesn't necessarily guarantee the optimal solution. The way that Bellman's does guarantee the optimal solution, and it's dynamic programming. And yeah.
Okay. So once we input the amount of orders we'd like to place, we create based off whichever algorithm we'd like to run, we create a smaller scale graph with only 2 + 1 vertices, and then we calculate the shortest amount of time it would take to complete the trips based off a custom-made greedy algorithm we created. And the greedy algorithm works based off starting from the source and going to the smallest distance vertice, and then from there going again from the smallest distance vertice until all of the locations have been visited.
And as you can see, it returns the total time for the trip, which is 611 in this case. And yeah, that's our project and that's our program.